Hi, I'm Tina from Prep 101. In this video, I'm going to teach you the derivatives of all the trig functions. Trig is important because there are lots of questions on exams involving trigonometry, and it tends to give students a lot of grief. So you really want to practice your trig. Okay, let's get started. Okay, so first thing we're going to do is review all 6 trig ratios and their derivatives. So we're going to look at sine x first. So if we have f of x equals sine x, the derivative of sine x is cos x. The derivative of f of x equals cos x is negative sine x, so be careful. Derivative of sine is positive cos, derivative of cos is negative sine. You need to make sure that you learn your derivatives thoroughly so that when we work with antiderivatives, then you don't mess up on your signs there, because that can cost you a lot of marks on exams. The derivative of tan x is sec squared x. And these three are less common on exams, but they do come up, so you have to memorize them just in case. So the derivative of sec x is sec x tan x. The derivative of cotan x is negative cosecant squared x. And the derivative of cosec x is negative cosec x cotan x. So get memorizing these right away so that you're not memorizing, things a few nights before the exam, because that becomes stressful. And if you memorize them now, then you'll get them engraved in your mind by the time you get closer to the exam and you're, doing practice exams. Okay, so again, one more time, derivative of sine is cos, derivative of cos is negative sine, derivative of tan is sec squared, derivative of sec x is sec x tan x, derivative of cotan x is negative cosecant squared x, and derivative of cosec x is negative cosec x cotan x. So now we're going to practice and do a whole bunch of derivatives. So find the derivative of each of the following. So number 1 here, we have f of x equals sine of 5x. So now we're adding the chain rule into the basic derivative of sine x. So we know the derivative of sine of anything is cos of the anything, and then by the chain rule, it would be times the derivative of the anything. So the derivative of sine of anything, cos of the anything, so cos of 5x, times by the chain rule the derivative of 5x, which would be 5. So our answer would be 5 cos 5x. Now, sometimes we put brackets around the 5x, sometimes we don't. It depends on the prof, it depends on the exam. So it means the same thing. If the brackets are not around the 5x, the angle is still 5x, even if there's no brackets. Okay, question 2 here. We have f of x equals cos root x. So we can write this, f of x is cos of x to the 1/2. So we go to do the derivative. Well, the derivative of cos of anything, derivative of cos x is negative sine x. So the derivative of cos of anything is negative sine of the anything times by the chain rule the derivative of the anything. And the derivative of x to the 1/2 would be 1/2 x to the negative 1/2. Now, how would we write that as in terms of a final answer? We would write this x to the 1/2 back as a root, so negative sine root x. This x to the negative 1/2 would come to the bottom to make it positive as an exponent. So it'd be the 2 stays on the bottom, and then it would be x to the positive 1/2. And then, of course, we know that x to the positive 1/2 is the same as a root x. So our final answer would be negative sine root x over 2 root x. And of course, you cannot cancel these root x's. This is an angle, right? This is sine of this angle. So be really careful about that. Okay, number 3 here. F of x equals x squared times sine x. So this has an x, this has an x. So that's an f and a g. So we have f prime g plus g prime f. We have a product rule here. So we do the derivative of the first. Well, the derivative of x squared would be 2x times the second, left alone. So times g is sine x plus derivative of sine x, derivative of g would be cos x times the first, the f, left alone. And they would factor this. So what can we take out as a common factor? We can take out an x. So we would have 2 sine x plus x cos x. And that would be our final answer. Okay, number 4, we have f of x equals e to the sine x. So hit pause and let's see if you can do this derivative. Think about the derivative of e to the anything is what? So the derivative of e to the anything is e to the anything times the derivative of the anything. So derivative of e to the anything, e to the sine x, times the derivative of the anything, the derivative of sine x. And that would be a cos x. And the cos x is down beside it. It's not up in the exponent. Okay, number 5. We have f of x equals a to the 4 plus cos squared x, where a is a constant. So there's 2 tricks here. Number 1 is they used a letter here as a constant, but we know the derivative of just a constant is 0, so there's no x in with the a, so the derivative of that will just become 0. And the other trick is that we're doing the derivative of cos squared x. And you have to be really careful. A lot of people mess up derivatives with the cos squared, sine squared, tan squared, things like that. So what you want to do is before you start, you want to write this as cos x all squared like that. That's your starting function. And that's because cos squared here, the square, really means cos x times cos x. So you want to make sure that you know that that's involving the chain rule, okay? So never, ever, ever think that the derivative of sine squared is cos squared, or the derivative of cos squared is negative sine squared. It's not, because it has to involve the chain rule. So the derivative here, derivative a to the 4 would be 0. Derivative of something squared would be 2 out in front. Bracket to the 2 minus 1 is 1. And then times the derivative of the bracket. And of course, the derivative of cos x is a negative sine x. So you can see the derivative of cos squared is nothing like negative sine squared. So be careful. It's negative 2 sine x cos x. Now we'll review lots of different trig identities at our prep session. So one of them that we're going to talk about that's really common is 2 sine x cos x. 2 sine x cos x is an identity sine 2x. So this would be negative sine 2x as the final answer. So on the exam, oftentimes they will sub in identities. If you get something like 2 sine x cos x without the negative, that would be sine 2x. Here we have a negative sine 2 sine x cos x, so that's negative sine 2x. Okay, number 6. So here we have sec squared of 2x plus 1. So think about what we do about the fact that we have a 2 there, right? This is really sec 2x plus 1 squared. So how do you write this before you start? So I would write it as sec 2x plus 1 all to the 2, like that. So how do we do the derivative of something squared? We do 2 out in front. The same bracket to the 2 minus 1 is 1. And now the tricky part here, times the derivative of the bracket. So let's think about what's the derivative of sec x. The derivative of sec x is sec x tan x. So that means the derivative of sec of anything is sec of the anything, tan of the anything, times the derivative of this anything, and the derivative of 2x plus 1 would be a 2. So that whole thing there is our answer to the derivative. So again, 2 out in front, bracket to the 2 minus 1 is 1, and then times the derivative of the bracket. And the derivative of sec x is sec x tan x. So the derivative of sec anything, tan of the anything, times the derivative of the anything, and the derivative of 2x plus 1 would be 2. So how would we write our final answer here? Well, we've got a sec times a sec of the same angle. We've got a 2 times 2 is 4, so we can say 4 sec squared of the angle, and then times tan of that angle, 2x plus 1. Okay, number 7 here. So we've got e to the tan x times sec x. Okay, I want you to hit pause and see if you can get the derivative right here. So we've got an f and a g, so we've got a product, f prime g plus g prime f. So derivative of the first, derivative e to the anything is e to the anything times beside the derivative of the anything, and the derivative of tan x is sec squared x. So all of that is f prime. Then times g. So again, derivative of e to the tan x is e to the tan x times the derivative of tan x, which is sec squared. So that's f prime times the second, which is g, plus now the derivative of g, the derivative of the second. Well, the derivative of sec x is sec x tan x, and then times the first. So that is our g prime, and that is our f. So I guess we could take out a common factor. We have a sec in both terms, and we have an e to the tan x in both terms. So we could take a sec x and an e to the tan x out in front. And what would be left here? We would have a sec squared. We've got the sec there. We've got the e to the tan x plus sec tan e to the tan. So we have the sec, so we would need the tan. And that would be our answer. Okay, number 8. So we've got f over g. So we've got a quotient rule here. So derivative f times g minus derivative g times f all over the bottom, or g squared. Okay, so the derivative of the top, the derivative of sine x would be cos x times the bottom minus derivative of the bottom, derivative of 1 plus cos x. Well, derivative of 1 is 0. Derivative of cos x would be negative sine x times the top, which is sine x, all over the bottom squared. Okay, so let's multiply this out. Cos x times 1 is cos x, plus cos times cos x times cos x is cos squared x. Now here we have minus a negative, so that turns into a plus. Sine times sine is sine squared x, all over 1 plus cos x squared. Now here we have an identity. Sine squared x plus cos squared x. Anytime you have sine squared plus cos squared of the same angle, so they could both be x's or both be 3x's or both be 5x's, but as long as they're the same angle, sine squared plus cos squared of the same angle is always 1. So all of that gets replaced with 1. So we end up with cos x plus 1 all over 1 plus cos x squared. And this is an interesting one because not only does it have an identity, but then it has canceling. 1 plus cos x is really what we have on the top if we switch the order. And we have 1 plus cos x squared on the bottom. So we can cancel one of the 1 plus cos x's. And our answer will be 1 over 1 plus cos x. Okay, I want to show you 2 questions that look really similar, but they're very different in terms of their derivatives. So I want you to ask yourself here, what's the difference between the derivative of number 9 and number 10 here? How are they different? Well, number 9 involves only the chain rule. There's no x with that cotan. But number 10 involves the product rule because they both have an x. So this one has an x, this one has an x, so this is our f and g. So be careful. Sometimes students make mistakes with derivatives and they miss the fact that there's an x or the fact that there isn't an x. So just be aware of that. So number 9 is just the chain rule. So the derivative cotan of anything is what we're thinking. So the derivative cotan x is negative cosecant squared x. So the derivative cotan anything is negative cosecant squared of the anything, negative cosecant squared of the anything, times by the chain rule, the derivative of the anything. And the derivative of sine x would be times cos x. And that would be our derivative for number 9. So for number 10, we've got a product rule here. So go ahead and write what you think the derivative would be here. So we have f prime g plus g prime f. So derivative cotan is negative cosecant squared x times sine x plus derivative sine x, cos x, times the first is cotan x. Now, we could use identities. So cotan we know is cos over sine, and cosecant we know is 1 over sine, so cosecant squared is 1 over sine squared. And we can add these up and get a common denominator and we can simplify. It takes quite a while, but you can also realize something that sometimes in your original, there could be an identity that you could use before you start. And this one has an identity. This is the original question, and cotan is cos x over sine x, right? Cotan x is cos x over sine x. So the interesting part about this question is the original question is actually just cos x. And so the derivative of cos x we know is negative sine x. Now, we can simplify all of this using identities and get negative sine x, but It's a lot trickier, isn't it? Right? It would take a lot of work to put in cotan is cos over sine, multiply that out, cosecant, 1 over sine, multiply that out, you get a common denominator. It's a lot of work. So sometimes you can look for identities in the question. So number 11 here, we've got cosecant cubed of bracket sine of 4x. So this one's pretty tricky. So first thing we're going to do is we're going to write this as cosecant of sine 4x all to the 3. Right? We know when we have a cube, then that's something cubed. So that's f of x. That's before we do the derivative. So the derivative of something to the 3 would be 3 out in front, then the something to the 2. And then that's the easy part. And then the hard part, we've got the 3 out in front, we've got the bracket to the 2. Now we've got to do the derivative of this, right? And that's not so nice. So the derivative of cosecant x. The derivative of cosecant x is negative cosec x cotan x. Okay, so the derivative of cosec of anything is negative cosec of the anything, cotan of the anything. And I'm still not done because the chain rule, we still need times the derivative of that anything. And the derivative of sine 4x would have to go beside it. And the derivative of sine of anything is cos of the anything times the derivative of the anything. So the derivative of sine 4x would be cos 4x times 4. And that is our derivative. So that's pretty insane, that one. So again, the derivative of something cubed would be 3 out in front, the something or the bracket to the 2, then times the derivative of this bracket. The derivative of cosec x is negative cosec x cotan x. So the derivative of cosec anything is negative cosec anything, cotan anything, times derivative of the anything, and the derivative of sine 4x, what's the derivative of sine of anything? Cos of the anything times the derivative of the anything. So the derivative of sine 4x is cos 4x times 4. And that's our derivative. And there's not a whole lot we can do with it. We could combine the 3 times 4, so we could do the 12. We could say cosecant of sine x squared times another cosecant of sine 4x. Those would be combined to get cosecant sine of 4x cubed. You can put the negative out in front, that's right here. So we could say cosecant sine 4x cubed, and then we'd still have the cotan of sine 4x, and we'd still have the cos of 4x. So we've got the 3, the negative, and the 4. That's our negative 12. We've got the cosec of sine x to the 2, cosec of sine 4x to the 2, cosec of sine 4x to the 1, right? This is 1 and 2, so that makes 3. And I should put a bracket around that. And then we've got cotan of sine 4x times cos of 4x. So we could write this with the 3 back here in the final. And that's about all we can do. Okay, try the last one, hit pause, and see if you can get your derivative here. So we've got sine of e to the t plus t e to the t. So this involves a chain rule right here, and this is a product rule. So f prime of t this time instead of x. So derivative sine of anything is cos of the anything times the derivative of the anything. So derivative sine e to the t is cos e to the t times derivative e to the t, which is e to the t, plus. Now let's just treat this as a new question. What's the derivative of t e to the t? Just like the derivative of x e to the x. So derivative of the first, derivative of t is 1 times the second, e to the t, plus derivative of the second, derivative of e to the t is e to the t times the first. So that's your product rule, f prime g plus g prime f. So again, derivative of t is like the derivative of x, which is 1 times the second, e to the t, plus derivative of e to the t is e to the t times the first. And we could take out a common factor of e to the t. and we would have left cos e to the t, plus here we would have 1, and here we would have t. And that would be our final answer. I hope you found this video helpful. If so, see more videos in this playlist. Don't forget to join the Facebook Study Hub. Use the link in the video description box. Also, I hope to see you at my prep sessions, where I'll show you lots of tricks on how to ace your exam. I'll go through every problem that you need to solve, and you'll solve them with confidence by the end of my prep sessions. Many of our prep sessions are free, so go to prep101.com now for more details and to sign up. I hope to see you soon. Take care. Bye.